This video is going to take you through Chapter 11, Section 3, which is the tangent line. So we're going to use a tangent line to find the slope of a graph. When you look at a graph such as these that have curves on them, we cannot find slope the way we typically do, where we just count the rise over run, because obviously these are curved. So what we're going to do is find the slope of a line that is tangent to the graph at a specific point. So if I were to just look at this first example, if I wanted to find the slope, I would find the slope at this point by finding a tangent line and then counting the rise over run. If we can't count the rise over run, we're going to work through a process that we'll get to in just a bit that involves the difference quotient. So in this example, again, if I had this point, I could count the rise over run. In this example, this is a horizontal line, so this would have actually zero slope. Well, it would have slope equal to 0 because it's a horizontal line. So the first kind of example is going to give you a graph, and it says use the graph to approximate the slope of the graph of f of x equals x squared at the point 1, 1. And in this picture, you have the graph of x squared, which is your parent function of your parabola, and it wants the slope at this point. And this goes as far as even drawing your tangent line and giving you your rise and your run. So the slope of that line can just be rise over run, or 2 over 1, which is 2. Now let's pretend we do not have the graph, or even if we have the graph, we don't have the slope drawn. Then we can find the slope of the graph using this process, which is called the limit process. In this process, the first thing we're going to do is find the difference quotient, and this goes all the way back to Chapter 1. And the difference quotient is found as f of x plus h minus f of x over h. Then we're going to find the limit of that function as h approaches 0 using direct substitution, which means we're going to plug 0 in for h, and we're going to simplify that. And from there, we will get some sort of equation with slope. So your mx plus b, which can just be the mx because b could be 0. From there, this is the first part, or the second part, is finding the equation that gives you slope. And then the last thing we're going to do is it's going to ask you for the slope at a given point, and we're going to take our x coordinate of that point, and we're going to plug it into the x value, and that will give us the slope of the curve at that point. All right, so again, let's walk through this process. And it is a tedious one, but it is the same steps over again. So if you can practice it, you should be able to do this. Example 2 says find the formula for the slope of the graph of f at the point x of f, comma, f of x. Then use it to find the slope at the given point. So the first thing we're going to do is find the equation of the slope by doing the limit as h approaches 0 of the difference quotient, f of x plus h minus f of x all over h. To find f of x plus h, we would take our x plus h and plug it into the equation. This equation is just x squared. So we're going to do x plus h squared. That's the first part. Then we're going to subtract from it the original equation, which is the f of x. And then we're going to put it all over h. Now we're going to do this step a lot. So I would say it's beneficial to memorize x plus h squared. If you forget, you can always expand it. So the shortcut for any function squared is you square the first term, you square the last term, and you double the product. So this would be x plus h squared. And again, we're going to use it a lot. So if you want to memorize it, we're going to replace x plus h squared with x squared plus 2xh plus h squared. Subtract from it the original f of x, which is x squared, and put it all over h. If you've done that step correctly, then anything that does not have an h should cancel out in my numerator. So I have a positive x squared and a negative x squared. They're going to cancel out. And then I end up with 2xh plus h squared over h. And if we've done that correctly, then h should cancel into each of the terms. And my simplest form is the equation that I am then going to find the limit of. So I get 2x plus h, and I want to find the limit using direct substitution of h as it approaches 0. So I'd get 2x plus 0, or 2x. And that is the equation that we're going to use to find the slope. This time we're finding the slope at the given point, which is negative 2, 4. So I'm going to take this equation, and I'm going to multiply it times negative 2, or plug negative 2 in for the x, and I get negative 4. So the slope at that given point would be negative 4. If I had actually graphed it, because sometimes we can actually visualize it, it would be a parabola. And if I wanted to know what was happening at negative 2, I'd go up to 4, and I'd want the slope at that point, which you can see would have a negative slope. And if we actually plotted it accurately, we could count it. The rise would be negative 4, the run would be 1. All right, let's try that again. Same set of instructions, find the formula for the slope of the graph, and then use it to find the slope at the given point. This time, my f of x is x squared minus 2x. And my coordinate point doesn't even give me the y, because we don't need it. All we need is the x value. So start with your difference quotient. F of x plus h minus f of x all over h. So first we're going to do the f of x plus h part. So I'm going to take x plus h and plug it in to my f of x. So I get x plus h squared minus 2 times x plus h. Then I'm going to subtract from it the f of x, which is my original equation. I'm going to put it in parentheses to remind myself to distribute that negative, and then I put it all over h. So first comes x plus h squared. This is x squared plus 2xh plus h squared. Distribute the negative 2 here. Minus 2x minus 2h. Distribute the negative here. Minus 2x, or minus x squared plus 2x. All over h. Remember, if you've done it correctly, anything without an h should cancel out. So x squared minus x squared, negative 2x, positive 2x. I've got 2xh plus h squared minus 2h over h. And each term should get an h canceled out, and I get 2x plus h minus 2. And then I want to find the limit as h approaches 0. So I plug 0 in for the h. 2x, this would be 0, minus 2, is the equation I'm going to use to find the slope. I want to find the slope at this given point, which this time my x is 3. So I'm going to take my 2x minus 2, and I'm going to plug 3 in. 2 times 3 minus 2, 6 minus 2, which is 4. Okay, so now we're going to learn how to find the derivative of a function. And there's a long way to do it, and there's a short way to do it. I'm going to show you the long way first, and then we're going to switch to the shortcut, and I would recommend sticking with the shortcut. So first of all, the derivative can be shown in a couple different ways. That f, this apostrophe, is read as prime. So this is read as f prime. This d of x over d, or d of y over d of x, y prime, d over dx times f of x, and d of x times y, all mean derivative. So the way we find the derivative is just the first part of that process we just did, steps 1 and 2. We're going to find the difference quotient, and then we're going to find the limit as as h approaches 0. And that equation is the actual derivative of my original equation. And we can use the derivative to find the slope of a curve. So it says, find the derivative. And we're going to do f of x plus h minus f of x over h. And then we're going to find the limit of that as h approaches 0. So take the x plus h and plug it in. 3 times x plus h squared minus 2 times x plus h. That's the first part. Minus f of x, which is my original function, 3x squared minus 2x, all over h. X plus h is x squared plus 2xh plus h squared Distribute the negative here, minus 2x minus 2h. Distribute the negative here, minus 3x squared plus 2x all over h. Distribute the negative here, and I get 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x all over h. Cancel out the things that don't have the x or the h on them. So 3x squared cancels with negative 3x squared. Negative 2x cancels with positive 2x. And I'm going to go ahead and divide my h's in. H cancels here, one of these, and here. I'm left with 6x plus 3h minus 2. One more step here, and that is find the limit as h approaches 0. So I plug 0 in. Eliminates this, and I get 6x minus 2. And that is the derivative of this function. So I can use that to find the slope at any point. Here comes the good news. The shortcut of finding the derivative is called the power rule. And what it is whatever the power is on each individual term, you're going to bump it forward, and you'd multiply it by what's on the front, and then reduce that exponent by 1. So let's say I had 2x to the 5th. I'm going to take the 5, multiply it times the 2, I get 10, and then the x stays, and the exponent gets reduced by 1, so this becomes 10x to the 4th. If it was a negative on the front, I would multiply the 3 times negative 3, it'd be negative 9x, and the 3 gets reduced 1, and it would be negative 9x squared. So you're going to do that for each individual term in your expression. All right, so let's go back to the one we just did, the long way, and find the derivative. 2 gets multiplied by 3, that's 6, reduce it 1, and that's x to the 1st. So we don't need the 1 because x is just to the 1st would be x. The exponent on the second term, 2 to the x, would be 1. 1 multiplies by the negative 2, so I get minus 2. Reduce this 1, and I end up with x to the 0. Anything to the 0 power is 1. So this becomes 6x minus 2, which is the same answer we got doing that very long process. Okay, find the derivative. 2 over x squared minus 4. So the first thing we need to do here is bring this guy to the top. Remember to move a variable with an exponent from the top or the bottom of the top, we change the sign on it. So this becomes 2x to the negative 2 minus 4. Now we bump 2 times negative 2 times 2, which is negative 4. Subtract 1 from here, and I get x to the negative 3. There is no variable here, so technically this is x to the 0. 0 bumps forward, and it cancels out that whole term. So a constant will always just cancel out completely when you find its derivative. Now I can't leave the negative on the exponent, so I leave the negative 4, but that x to the 3rd is going to go back to the denominator. And last up, now we've got a square root. So hopefully we remember that a square root is the same thing as an exponent that is 1/2. The 1/2 is going to bump forward, and we subtract 1 from it. 1/2 minus 1, or 2/2, is a negative 1/2. So the exponent on the x minus 4 is negative 1/2. The negative brings it back down to the bottom, so I can make this 1 over. And an exponent that's a half is the same thing as the square root. And then we just combine these together. 1 over 2 times the square root of x minus 4. All right, that wraps up the notes for 11.3. You can use the remaining time to work on your assignment.